All right, welcome back to Workplace and Apprenticeship 30. We're continuing with section 1.3 and starting with example 2 on page 53. Here we're comparing highway fuel economy versus city fuel economy. So the highway is in green, but on your sheet you won't be able to see that very well. So please just label your line highway and the bottom line city. Okay, then if we look at question number 1, it says, does the correlation between variables appear stronger for city or highway driving? So if you look at these, all of these points surrounded by the lines, the city driving has the points more closer together to the line of best fit, whereas the highway driving, the points are more spread out. So the stronger correlation would be for city driving, because the points are closer to the line of best fit. Okay, then question B is the relationship between fuel economy and vehicle weight a direct linear relationship or partial? So remember, in order for it to be direct, it would have to pass through the origin, or the points 0 and 0. So can either of these lines actually go through 0 and 0? No, they can't. So it would be a partial linear relationship. Because the line of best fit does not go through 0, 0. Okay, then part C, write two equations that can be used to determine fuel economy compared to vehicle weight for the two driving conditions. So to do this, we need two things to plug into our y equals mx plus b formula. We need the slope, which is m, and b, which is our y-intercept. So let's split our page into two. There will be city and highway. I will do the highway one with you, and then you can try the city one on your own. So we know that slope equals y2 minus y1 over x2 minus x1. So we need two different points from our line of best fit. Just from looking at that line, we can see that at 14 and 1200, it meets. So that would be about right there. 1200 and 14. Also at 1900 and 10. So about right there. So we're going to use those for our 2 points. Again, it doesn't matter which is y1 and y2. So let's say that this is x1, y1 and x2, y2. And go back and plug them into our formula. So y2 is 10, y1 is 14. x2 is 1900, y2 is 1200. Now before we get to this slope, is the slope going to be positive or negative? Negative, because the line is in a negative direction, or it goes down from left to right. So your final answer here should be negative 4 over 700, which, let's put that into a decimal, to be negative 0.006 is our slope for highway driving. Okay, so that's our first step. Our second step is to find B. Now remember that you can find B by plugging in your slope and your x and your y coordinate into this equation. So let's use the point 1900 and 10. So 10 is our y value, our slope is negative 0.006, our x value is 1900, and then we'll add b. So we want to find b by itself. So here our first step would be to multiply. So we're going to multiply negative 0.006 by 1900. Move it to the other side, and you'll find that b equals 21.4. So now our last step is we want to rewrite this into y equals mx plus b, where y and x are both variables. So we'll get y equals negative 0.006 x plus 21.4 is your equation for the highway driving. All right, then on your own, go ahead and try city driving. Right, so you should have got your slope to be negative 0.05, your y-intercept to be 16.5, and then your final equation would be y equals negative 0.005x plus 16.5. Part D says estimate the city and highway fuel economy of a vehicle weighing 900 kilograms. So is that 900 your x or your y? It'd be your x. Good. So x equals 900 kilograms, and we need to plug it into each of those equations. So for the city, our formula is y equals negative 0.005 x plus 16.5. So we're subbing in 900 for x. And you should end up with about 12 kilometers per liter would be your fuel efficiency. So go ahead on your own, try highway. All right, just double check your answers with mine on the board. You should have ended up at 16 kilometers per liter for highway driving. Next, we're doing mental math. Please do not use calculators for this, although I don't know how you would. We're talking about peak water level as the years have gone by. So here we don't have a scatter plot, but we do just have a table of values. So I want you to look at these values. Is there a general trend? So you could say that here we're starting off with 5s and 6s, and then we go to 6s and 7s, and then we end up with 7s and 8s. So overall, it would be increasing. So it appears to be increasing. Now we need a reason why. So there's a bunch of reasons why. All of them, or most of them, would revolve around global warming. Because global warming, melting glaciers are increasing all water levels, but also with higher temperatures comes more precipitation. So those are two reasons of why this might be happening. Okay, last you have an assignment to work on, page 60, number 5, 6, 7, and 8. I have blackline copies for you in your notes, and they're actually on here in the last couple slides, so that you don't have to draw your own graphs. You can just use these ones I provided for you. And this lesson is brought to you by another student in our St. Brew class.
Metro Honor.
All right, he froze up, but that's okay. He'll bring another one.